All right, let's look at our first word problem here. I'm going to read it once and picture what's going on, and then the second time we're going to look for important information. Jessica and Carl run at constant speeds. Jessica can run 3 miles in 24 minutes, and Carl can run 2 miles in 14 minutes. They decide to race each other. As soon as the race begins, Carl trips and takes 2 minutes to recover. So quickly, what I'm picturing is two people are racing. I don't know if they run the same speed or who is faster yet, but I know that they're racing each other, and Carl kind of gets a delayed start because he tripped and fell. So he didn't start right away. I'm going to read it for a second time now and pick out some important information. So as I'm going to highlight anything that has to do with Jessica in red, anything that has to do with Carl in blue. So here we go. Jessica and Carl run at constant speeds. Jessica can run 3 miles in 24 minutes, and Carl can run 2 miles in 14 minutes. They decide to race each other, and as soon as the race begins, Carl trips and takes 2 minutes to recover. All right, so I know I have my information here. I'm going to picture it kind of try to on the graph, just to see if I can get an idea for what I'm looking at. So I know Jessica begins right at the beginning of the race at time 0, and she can run and run and run and run and run and run. And she gets to 3 miles, if you look at my y-axis, 3 miles in 24 minutes on my x-axis. So she was running, that's how far she made it. She could keep going, right? And she would keep running another 3 miles in 24 minutes. And let's look at Carl. So I know Carl didn't start right at time 0 because he tripped and fell. He started 2 minutes later. So as he was running, he can run 2 miles in 14 minutes after that. So 14 more minutes. Well, we already wasted 2 on the ground because he fell. And so I would be at 16 minutes and he can run 2 miles. So it looks like he's maybe getting closer, but let's figure out if he ever does catch up to Jessica. We're going to use an equation to help us out. So I've already moved our highlighted version over here. And when we write an equation, we need 2 things always. We always need the slope, and we need some sort of point. Either it's the y-intercept or any point. So for this first one, I'm trying to find the rate or the slope. And something we want to think about it being is the distance over the time. So for any of the problems that you're working with today, you're always going to put the distance over time, like miles per hour. So for example, for Jessica, she can run 3 miles in 24 minutes. So her rate is 3 miles in 24 minutes. We can simplify that because both of those are divisible by 3. So if I divide 3 divided by 3, we get 1. And if I simplify the denominator, 24 divided by 3, I get 8. So she can run 1/8 miles per minute. And that's my rate or my slope for this equation. She doesn't need another point because she started at 0, 0. That's actually her intercept. So y equals 1/8 x is our equation for Jessica. Now Carl's is a little trickier because he tripped and fell. We always need the rate though. So the rate is distance divided by time. So Carl's distance is 2 miles, and he could run that in 14 minutes. And I see that this fraction can be simplified again. So his is, they can both be divisible by 2. 2 divided by 2 is 1 in the numerator, and 14 divided by 2 is 7 miles per minute. Well, my rate, I noticed my equation for my second equation is a little different. We need a point to represent that Carl took 2 minutes to recover. He started 2 minutes after, or at 0.2, 0. Now I'm going to fill out my equation, and this time I'm writing it in point slope form because I have both a point and a slope. So I'm going to do y minus y1, which is 0, equals m, which is our rate, 1/7, and x minus x1, which is 2. Tricky part here, the x and the y kind of switch, so they don't go in the same order. You gotta kind of flip them. So my final equation here is y minus 0. Well, I don't always write minus 0. We probably could write this as just y equals 1/7 x minus 2.